but if your attendance is 70% or more, you can request for a makeup. So you can start making that request next week, not this week. I want to finish grading the remaining assignment so that you know where you are in the class before you can make the request. Okay? So Monday next week, if you look at the attendance and it's good, you can now email me the request and the list of 4 assignments or 2 or 3, whatever, but not more than 4 that you want to make up.
Hello.
So, can you mute yourself? Who is
No, I have a question.
1 minute? Let me know who is.
Okay.
Okay. All right. Yeah, what is your question, sir?
So for the classwork 10, the normal distribution, is it due today or tomorrow?
It's due today, but I will still accept it tomorrow.
Okay.
As usual.
Okay.
I normally it is usually due on the day of the class, but I still accept it the following day. Anybody have a question, you can ask me here. I don't answer question in the chat room. Okay. So now let us look at this screen. For this week, we'll be focusing on normal distribution. We're now in model 5. As soon as we finish the class, I'll put the classwork here for you. So the classwork will be done like as Excel. So I would like you to pay attention as I show you examples as we proceed. And your homework is homework 7. You can do them with Excel as well. Just put your answers in, and the assess Pearson in the Pearson. So let's begin. Normal distribution. Normal distribution. Many continuous variables. Many of them can be things like, for example, the height. As an adult, there's a certain height we expect an adult human being to have. Like somebody who is already a teenager or in his 20s, there's a certain height we expect them to be. How about temperature? That's what they call normal temperature. Normal cholesterol levels, things like that. They are good examples of continuous variables. And many of them have distributions that are bell-shaped. Bell-shaped. So we call them, we give them the names normal distribution or bell-shaped distribution or Gaussian distribution. Okay? So the last name, which is Gaussian, is after the German mathematician who derived the equation. His name is Carl Frederick Gauss. So the normal distributions simply means, based on this background, a continuous symmetric bell-shaped distribution of a variable. And we can use it to describe many variables since deviations from this normal are very small. Look at the bell curve that show how the normal distribution is. You can see half of this curve. Half of this curve, half of it is almost the same as the other half. You can literally fold this part into that part. So we say that it's symmetric because symmetric sides. And it has the mean, median, and mode at the center. And it has an asymptotic tail. We mean that this line doesn't never touch, this is the x-axis. This line never touches the x-axis, even though it gets closer and closer, but it doesn't touch it. So that means, and this side is 0.5. This side is 0.5. So the total area in the normal curve is 1, which means 100%. I mean, it's 0.5 plus 0.5 which is 1.0, which is 100. More example, like there's a normal range of the systolic blood pressure, which is usually 110 to 140 millimeter mercury. If yours is bigger than 140 or less than 110, that's not normal. Okay. There's a normal interval for a person's triglycerides, which is 30 to 200 milligram per deciliter. Anything above that is not normal. And we have the average birth weight for human babies, which is approximately 6 to 9 pounds. A baby that is bigger than 9 pounds is says to be overweight. And if the baby is the newborn baby weighs less than 6 pounds, I mean she's underweight or he's underweight. With this, we are now ready to look at the properties, some of the properties of the theoretical normal distribution. Okay. The first property is that a normal distribution, let me make it a little bit bigger, maybe 18. The first property is that the normal distribution curve is bell-shaped. As you can see from here, it's shaped like a bell. Okay? And the mean, median, and mode are equal and are located at the center of the distribution. You can see them right here. Mean equals median equals mode and located at the center of the distribution. Yeah. Then the curve is symmetric about the mean. Yes, you can see that that this part is almost a mirror image of this part. Okay. It is unimodal, it has one mode, and the curve is metric, okay? Now, it is continuous and there's no gaps. Yes, you can see from there, no gaps. Okay? Now, the curve never touches the x-axis, and the total area is equal to 100%, which is, I just showed you a few minutes ago, 1.5 plus 0.5 is 1.0, which is 100. Now, then let's see how to calculate the area under the standard normal distribution. Let's see how we can do that. It's usually better to draw the curve and then find the area. But since we're using the Excel, I showed you some of the commands. Let's look at part A. Part A says, the question says, find the area under the standard normal curve, which lie A to the left of Z 1.76, B to the right of Z 1.76, C between Z negative 1.87 and Z 1.28. So we use Excel to get it. But I want to show you this. Let's start with the A. A says to the left of solution. Okay. So to the left of Z 1.76. So you can just do I put 0 here. Excuse me. Sorry. 1.76. Excuse me. Sorry, it's my allergy. Then you can put the and draw the curve. Yes, I put the line here. Okay, and then we have starting from here and go up. I'm drawing it just to show you something. If you know the Excel formula, you might understand it very well. You may not need to draw the curve. Okay. And then you have the center line, which is the mean. Okay. So it says to the left of Z. This is Z 1.76, so I'm going to put this right there. Z 1.76 right there. And it says to the left of that. This is the left of that. So I'm going to shed the left of that. Okay. Okay, and then this we go. And so on and so forth. So I'm drawing it because I want to show you how it looks to the left. So we're looking for the area to the left. The area will be So to the left of 1.76. Now I showed it. This is the I wrote. If you see what I wrote here, I say hint on using Excel. Let me make it. It says for part A, which is the left of the z value, where z is greater than the mean. You can see this is the mean at the center, and this z is bigger than that. It said to use this formula. So you can use this formula, okay? And we need to put this. We use this formula. So we're gonna use this formula. I'm gonna put it right here so you can see it. Since we're using Excel. So how do we use this formula in Excel? We have our z. Let me write this down. I have the formula equals num dot s dot dist parentheses z and true. True because we're using cumulative. Now, our z is what? Our z was given as 1.76. So 1.76. So you can go to Excel and then open your Excel and put your work there. Okay. Part A. So our z equal. Okay, good. Z equal 1.76, right? 1.76. Again, the formula to use, I have it there. Actually, I have it even listed and below here for part A, for part B, and part C. You will see it on the handout that I uploaded for you in the model. So, you can see the num.s.dist, then z, the value of z and comma, and then true. So that gives us the answer right away. So this is z. So the area we're looking for, area is the same as the probability equals num dot s dot dist parenthesis, opening parenthesis. Then for a z, you click on z here, comma, then type true, then close the parenthesis. That's give you then when you press the enter key, to give you the answer right away. So 0 point, area will be 0.9. Let me make it 4 decimal places because usually what would have it. 0.9608. Okay. So we have our answer. So when you're doing the classwork, this is what the spreadsheets where you did the work in spreadsheet, the way I'm doing it now, that's what I'm expecting you to submit to me. So have it at area becomes 0.9608. 9608. Any question on this? Any question, guys? Okay, there's no question. Good. So let's try on part B. Part B says to the right of z 1.76. For that, I draw this chart just to show you how it will look. But it will be a help for you to draw it before you can do the work. Or you can just use a formula. Like I say, part B says, it says, for part B, z is, let me make this into be big. Okay. See part B, z is in the right tail. Because it says here, the right of C 1.76. So it says Z is in the right tail. So use this formula here. The formula right there. 1 minus number of this. So let me write the formula down. For part B equals 1 1 minus num dot s dot dist. Z, comma, true. That will give you your answer. Okay. So we have this we go here and put our work right here, part B. So Z is still giving the same 1.76. 1.76. Okay. Then area equals, now again, you now apply that Excel formula right here. Num dot 1 minus num dot S dot this. Where the Z is the the Z value given for part B. Let me write part B here. Part B. So the formula we'll be using is this one here. Let me just copy and put it right there. It's right here. Write the solution. Okay. We're using this formula right here. I'm going to bring somebody in. Okay. So our area we're looking for, I'm going to bring it down. So we have enough room. The area we're looking for now becomes Z is still the same Z. Z is giving us Z equals 1.76. They say 1.76. So let's go and put this in N to get our answer. Let's go to Excel. The area will now become equals 1 minus, I wrote it down already, 1 minus num dot S dot dist. Opening parentheses, click on your Z, which is 1.76, comma, then type through. And press enter. That's the answer right there. You can make it for the smart places. Usually that's what you have, which is area now becomes 0.0392. Okay, so you can go and put it right there. 0.0392. So again, is there any question for me on this? Okay, no question. Good. No, very good, good. Now, the question I'll be asking it in a different form, like this one, is say between Z equals negative 0.87 Z equals to 1.2. It's between two Z values on the opposite side. That's part C. Okay. Excuse me, C. Solution. I'll put it right there. Part C. That solution between these two Z the values on the opposite side. For that, I say use this formula here. Part C. Norm dot S dot dist for Z2. True minus num dot S dot dist for Z1. True. Let me just write it down and then we can work on that equation. Okay, equals num dot S dot dist. Okay, Z2 true minus num dot S dot dist. Okay, Z1 comma true. And that will give us the answer right away. So I'm just going to copy it and put it there so you can know where we are using it. Otherwise, alternatively, you can draw the chart, like I draw the first one, and then use the table of normal distribution to find the answer. Okay? So this is our Z1, The first Z becoming a Z1, the second Z becoming a Z2. So in this case, let's go and put this in Excel. We have part C, Z1 equal negative. Oh, I didn't copy the question. Let me write the question out. Sorry about that. So as Z1 equals negative 0.87, Z2 equals 1.28. So that the area equals, as area, this is actually the same as the probability. So let's go and put this in and got the area. So Z1 negative 0.87, Z2 equals to 1.28. So we have that the area, which is the probability, excuse me, becomes, once again, let me just show you the formula so you can see it again before we now calculate it. Equals num dot s dot this, parenthesis z2 comma true, or minus num dot s dot this, opening parenthesis z1 comma true. And of course, true means that we are using cumulative probability, distribution table. So now let's find the area now. Area becomes the area becomes, I'm gonna make this okay, equals area we're looking for becomes let's go and put it on that place, and then we can get our answer. Equals num dot s, okay, num dot s dot dist, opening parenthesis, z2 first, comma, true, close parenthesis, minus num dot s dot dist, okay, z1, which is this, comma, true. And when you press the enter key to give you your answer, they can make it make it two decimal four decimal places, which is 0.7076. Okay, I'm going to type it there. 0.7076. I can call it 70.76%. So these are how you can use Excel to get the answer for the normal distribution equations when you're asked to find the area and you're given the z value. Okay. So now, having a now I can this question might be asked in a different form. It might be asked like in this form where it will appear as a probability. It's basically the same thing. Yeah, z, and then apply the Excel formula. Let's try the first one, maybe two of them, and then we'll look at the application of it. Look at this one. It's a between it's a probability. Let's try it right here. It's a find the probabilities for each using the standard normal distribution. A part says probability of 0, solution, here, okay, equal. Now, how do you get it? Can say this simply means probability of between 0 and 1.45. And for that, I gave you this formula here. Use this formula. Okay. Num dot s dot this. Okay. Now, some people ask me, why subtract 0.5 from this? Why? Because remember I showed you that here the normal curve, this is 0.5, this is 0.5. So for this particular one, if you draw the chart, it will look like this. Okay, this one is, I'm gonna put 0, 1.45. And then when you put the chart in, it's gonna look like this. Oh, excuse me. Okay. I can move it a little bit and then move this one a little bit. So, okay. Now I can put the center line inside the center line, which is at the 0, and then put 1.45 line. So that it's between 0 and that. That is the area we're looking for. Yeah? This is the area we're looking for. But the entire side is 0.5. I'm just trying to explain to you why we're subtracting 0.5. Okay? One more. Right here. So you can see that the entire side is 0.5, but you're looking for only for this shaded point. So you have to subtract, whatever you get from 0.5 to get only this part. That's why you say minus 0.5. So that's what I'm trying to explain. And let's look at the formula. This part A is equals norm dot s dot dist z comma through minus 0.5. So to then apply it here, I'm going to take it in this case as z.
Yeah. Like, come on. See, I thought you watched
1.45. Please, can you mute yourself, please? So the probability we're looking for P is 0 less than Z less than 1.45. So that we can go there with the Excel. Okay. And put it here. Okay. So you have this at A, excuse me. A. So our Z is equals 1.45. So that the probability we are looking for, probability will be, we apply this from right here. This one right here. Okay. So the probability now becomes equals norm dot s dot dist. Okay. Z, click on Z, comma, true, type true, close the parenthesis, but then you're going to do minus 0.5. And when you press the enter key to give you the answer right away. And of course, make it to the smart place. I mean, for the smart places, which is 0.4265. Any question on this? Okay. No question. Good. Now I wrote under it, I wrote, for example, for part B here, I wrote the Excel formula you can use. For part C, I wrote it right here. And I explain why you're using it. For example, part C says where Z is on the right tail, use the Excel formula right here. Because why is it on the right tail? Because it says Z greater than 1.65, which is this way, the right side. So each of them, I wrote the formula for it, so you can use it to practice. Let's do one more example there. Look at this example here, where you have part E, 1.45, probability of 1.55 less than Z less than 2.97. Let me write it down. Part E. So you can use that formula. These formulas are listed here for each part. For part E, part D, part C, and to solve them. Let's look at this one, part E, where Z values, two Z values, Z1 and Z2, on the same side of the main, where both Z1 and Z2 are either negative or positive. You can see this one right here. They're on the same side. Both of them are positive. How do you know that they're on the same side? You know that they are on the same side when both of them are either positive numbers or negative numbers. That means negative. Here, they have, this one is positive, this one is positive. So they're on the right side. But on this type, when one of them is negative, that means they are on opposite side. For that one, you use the formula for D, which I have here for you. So let's try the part E, which is, let me write part E down. Okay. Part E is probability of 1.46 less than Z less than 2.97. Okay. So for that case, this is the Z1, this is the Z2. So Z1 equals 1.46 and Z2 equals 2.97. So we'll be using that formula for it. I wrote it down here for E equals norm dot S dot this. Z2, comma, true, minus norm dot S dot dist Z1 true. Okay, that'll give us the answer right away. So let's do part E here. Okay, part E. I'll write it here. As a matter of fact, I can just copy it from here and paste it there. Okay. Part E. What is it? Okay, right here. Part E. E, oh, excuse me. E solution. Okay, have it equals. So this is our Z1, this is our Z2. Again, the formula will be, I'm going to just copy it from here, paste it here for you, so you'll be looking at it. That's the formula right there. And I'll make it 16 font. Okay, or if you like, I can just highlight it for you so you can see it clearly. Okay, so having said that, let's go and put our numbers in Excel. Part E, Z1, okay, equals 1.46. Z2 equals 2.97. Okay. So that the required probability we are looking for equal. I'm gonna make it okay. So, and of course, the probability is right here, written in this form. And this simply means between 1.46 and 2.97. So we apply this Excel formula now to get the answer. So it will become equals norm dot s dot dist, okay, z1 z2 is right here, comma, then true, close the parentheses, minus norm dot s dot dist, open parentheses, z1, which is this one here, comma, then true, and close parentheses. Now press the enter key to give you the answer right away, which we just convert to 4 decimal places, 0.0707. So 0.0707. Okay, let's go and put it right here. I have 0.0707. Any question on this? No question. So you can use the formula to do B, C, D as a practice. The formulas are right here. Right? For each part, I have to have the formula written there. Now let us go to the how to find the specific z values. That's doing the opposite of what you just did. Finding specific z values that correspond to the given area that we have. For that, we use the formula. I listed the formula right here. In this case, we are given the area. That means you are given the probability. And you are asked to find the z value. So we are doing the opposite. So for that, use these formulas right here. If it's on the left of the tail, use num.s.this, num.s.inverse. Then put the area in. And if it is to the right, then num.inverse num.s dot inverse. Okay. Then 1 minus area. Yeah. Now, if it is between two tails, you use this one. We're looking for two tails. So let's try the first one. I mean, you can use the example for the rest of them. You have area is given as this. Part A. Part A, let me put part A here so we can solve it. Part A. Okay, the solution. Okay. Maybe you can make it 18. So it says to the right. Okay. So that z becomes equals. They're asking us to find the z values. Okay. So we can call it solutions. So I do all of them. Now the z value becomes it says to the right. It says if it is right, I'm gonna use this formula, num.s.inverse. And we'll just copy it and paste it there. Okay. Num.s.inverse. So let me write this down. I'm gonna draw a line here. So for A, the area is giving us 0.4066 on this right. So that the z becomes, now the formula we use is equals norm.s.inverse, then type the area. So let's go and do it on the Excel. Okay, part A, the area is giving us 0.40, okay, and then the z will be equal norm dot s dot inverse. because it's set on the right side. So you're going to use this. Click on parentheses, open parentheses, click on the area, then close the parentheses. And then press give negative. Excuse me. So, but you know, this is one mistake that Excel makes sometimes. It says negative, but actually probabilities cannot be negative. So you just don't put negative answer, just remove the negative sign and put it name. Okay. So you're gonna be 0 point. Oh, sorry, a mistake. I did something that is not correct. Is the inverse. So norm dot s dot inverse. Yeah, parenthesis. This is probability. Okay. Uh, 2.4. You know, it says on the right. Okay. For the right side. Give me a minute. Let me check, just verify something, and then I will get back to you. Okay. One thing. Okay, left it there. Yeah, I use the one for the right there. So let me correct this. Okay. For the right, yeah. Left there area. I use the one for the left there. Excuse me. Yeah, this is for and I even corrected it here. Left there. This is for left there. So I should use this one. The one I'm supposed to use this one, not this one. So I'm going to just correct it. Okay, I'll remove this. Just this is for the right there, because it says right here. And I even wrote it down here for the right. For the right there, use this one. So this is one we're supposed to use here, not that one. So I'm gonna this. Put it under. So now let me correct myself. It's gonna be 1 minus the area. So now I can take it down back to that place. So for equal, just norm dot s dot inverse. So you're going to be 1 minus area, 1 minus the area, which is this one here. Then close parenthesis. Press the enter key. 0.23, because usually the z value, we leave them at 2 decimal places. So 0.24. It's answer 0.24. 0.24. Okay. Let's try part B. Part B. It says for the left area, okay. I'm going to just copy part B. Part B, let's copy right here. I'm going to put it right here. Okay. Part B, make it 18. Okay. Now this is left. And for left, use this one here. So I'm going to copy this formula. Because it's on the left side, it will be negative. Have a negative, this thing. So that z now becomes, excuse me. So that's part B. Area is 0.4175. So that z becomes, and for z, you're going to use equals norm dot s dot dist, then area. So that's what it says for the left there. So we're going to go to the Excel and put part B, excuse me, B, area is given us 0.4175. So that Z equals norm dot S dot dist. Okay. Oh, not this, some mistake. That's inverse. Put in parentheses. Click on the area, which is the probability. Close it. Then press the enter key. Negative 0.21 approximately. So we've got two decimal places. Negative 0.21. Okay. Sometimes it can be, let's try another one. Which is part C, and it's right. It's to the right side. Part C. Once you know how to get this in, now the normal distribution program becomes easy for you. So I'm gonna make this one to be again like others. It's font size 18. I mean to say this was right. So for right, we're gonna use this formula here. Instead of use 1 minus area. We're looking for Z. We're gonna use this formula here. That's the formula. Find it. Write it down. C. I got area equals 0.0239. Then Z equal. And we're losing norm, okay. So we have, let me go and put it in. It's right. So you got part C, area equals, and then Z equal. Area is given as 0.0239. So that the Z becomes norm dot S dot dist dot inverse. Put in parentheses, click on the probability, close it, and press enter key. This is, hold on, let me make sure. Let me make sure. This is right. Yes, this is right side. Right there, yeah, right there. Almost area. Yeah, the right there. Okay, and left there. One minus, oh, I didn't do 1 minus area. I see what I mean. 1 minus area. It's gonna be 1 minus area. 1 minus area. Then press enter key. 1.9, basically 1.98. 1.98. It's positive. So 1.98. Oh, excuse me. I gotta show you this. So let me put it right here. This is the area. Okay. This is the area right here. We're looking for this area. So we're looking for the Z value. So now I'm going to take it to Excel. I'm going to try it again. It will be equal norm dot S dot inverse. Okay. Then this time around, because it's on the right side, I'm going to do 1 minus probability. Close the parentheses. Then press enter key. 1.98. If it doesn't give 1.9, if you give you more numbers, you reduce it to 2 decimal places. So we're going to go back there and put 1.98 as the answer. So you're going to be 1.98. 1.98. Okay. So I showed you all this, how to get all of this. See, left, right, left, right. And see all the formulas for each of the three formulas you'll be using, whether it's left or right. And if it's on two sides, you use this one. Let's do an example that involves that. That example is number 4. It says oh no, it's the same. They just ask the question as a percent, but it's just like getting just change it to decimal. Let's do it. Find the z value to the left of the mean. That's the key there. Find it and make it bold. 18. Such that 98.87% of the area under the normal curve lies to the right of it. So I'm going to bring this one down a little bit. So for this one here, solution, yes, solution. The area given is 98.87%, which is, if you change it to decimal, 0.9887. Okay? Let me make this into the 18. Okay? Now, I'm looking for the z to the left. So let me write this down. Area is given as 98.87%, which is 98.9887. Then z equals, I'm going to be using, for this one, we'll be using this formula here for the area, because it is, say, to the left. And you know that to the left, we're using this formula right here, to the left. See? So I'm going to just write it down. Norm dot s dot inverse and area. So let's go and put it on the calculator and on the Excel and get our answer. So you have question 4. Okay, we have the area equals 98.87%, which is 0.9887. And then the z we're looking for now becomes equals, make sure I see this, okay, equals norm dot s dot inverse, okay, area is probability right here, close the parenthesis, and then you press the enter key. Okay, this is to the this is to the left, right? Let me make sure this is to the left. Let me make sure. Yeah, to the left. Yes, to the left. So for sometimes I said if I don't know whether it just forgot to put a negative sign, because it's to the left. So you gotta put negative sign. So you gotta be negative 2.28. Okay. So let me put it right here. So you gotta make it 2 decimal places. Yeah. Negative 2.28. Negative 2.28, because it's on the left. Any question on this before we go to the next, the application? Any question? Okay, no question. Good. You can now go to the application. So before we go to the application, let's look at the standard normal distribution. The standard normal distribution simply means a normal distribution with a mean of 0 and a standard deviation of 1. So, and we can transform all normally distributed variable into the standard normally distributed variable by doing one thing. We use this formula here, z equals x minus mean over standard deviation, to transform it, that normally distributed variable, into the standard normal distribution variable. In this case, S represent the data value, 0 represent the standard score, mean represent the mean, and delta represent the standard deviation. Let's try the one example here. So what it means that we transform it to this the value to a z value, and then we apply these rules here to solve the question. Let's look at this question. It says we use it under the application of the standard normal distribution. You say that the monthly excuse me. Give me 1 minute. Okay. It said the monthly utility bill in a city are normally distributed with a mean of $100 and a standard deviation of $12. A utility bill is randomly selected. Let me make this 18. So a utility bill is randomly selected. Find A says find the probability that the bill is less than $70. B, find the probability that it is between $90 and $120. Then C says find the probability that the bill is more than $140. Now, again, all these numbers, you have to change them to a Z first before you can apply the Excel formula. So what we're going to do now is, let's write the first one. First of all, our mean, as a matter of fact, that's what I wrote here. And I say for part A, use this formula. For part B, use this Excel formula. And for part C, use this. So for our solution, let's look at our solution. A part. Part A, I'm going to make this into be 18. A, before the A, you know that the mean, our mean, we use the symbol for the mean. The mean equals, according to the equation, $100, and the standard deviation is $12. So the mean is $100, and the standard deviation, we're gonna use its symbol, is $12. So, and for A, it says find the probability, okay, that the utility bill is less than $70. So for A, X is $70. X equals $70. So let us transform this using this formula here. I'm going to copy the formula here. Just plug in numbers. This is the formula right there. So this will give us equals, make it 18. So that X, which is 70 minus mean of 12, mean of 100, close the parenthesis, divided by standard deviation of 70 of 12. So this we can get from with our with the help of our calculator. And let me write the values down, then we can go to a calculator. Okay, I got at A 70 minus 100 over 12. So we're looking for the Z okay, so that will give us our Z. So we have we got 70 minus 100 divided by 12, negative 2.50. So negative 2.50. So our Z, it is no longer 70, it is now negative 2.50. See, it has been transformed from X to Z. That means from 70 to 2.50, which means that the probability that the bill is less than 70 becomes what is it? Becomes that the probability of Z less than 70. Sorry, less than negative 2.50. In which case, it says for part A, we're using this formula because the Z is on the left tail. See, because it's on the left tail. So we use this formula right here. And I'm going to put it just below it so you can be looking at it while we do it. Okay? Because on the left tail, we're using this formula here, this Excel formula. So it becomes, answer now becomes Z less than negative 2.50. So we can now go and put this on Excel. Okay. We got okay, have Z equals negative 2.50. And remember the formula they give us like I said, say on the equation I mentioned here, for part A, use this one because Z is on the left tail. For part B, I say use this one because Z is between two Z values, Z1 and Z2 on the opposite side. And for part C, use this. And I give the reason for each of them. So this one, we're using this one, norm.s.dist and Z, comma, true. And that will give us the answer we're looking for. So we can, where are we? Where is it? It's right here. So let's go and get it on Excel. So that the probability we're looking for that it is less than equals num.s dist parenthesis opening, click on Z, comma, then cumulative true. Close the parenthesis and press the enter key. 0.0062. Now, so you gotta make this 4 decimal places, 0.0062. Yeah. So which means that the probability we're looking for that is less than $70 is 0.0062. So that answer part A. Any question on this before you go to part B? Any question? Okay, no question. Good. Now, part B says, find the probability that the utility bill is between $90 and $120. Now, we have two Z values. They gave you two numbers. That means you're going to get two Z values. Okay? I think I'm going to need another paper. Two Z values. We'll have, let me use this one, paper. Need paper. Okay? I use this one. Yep. This is good. Two Z values. We need now part B. So you have the first one is this X1 is $90. X2 is $120. So let's go and put it for part B. For part B, oh, excuse me. For part B, okay, between X1 is $90, X2 is $120. Okay, have it. Okay, so we're gonna transform both of them. Let's transform x1 using this formula here. I have it right here. We call it z1. z1 will be oh, and you know our standard deviation is 12. Mean is this, and the standard deviation is 12. So I'm going to copy this and put them here first of all. Okay. Oh, excuse me. So that we have x1 and x2. So you're going to be equal for the first one, which is z1. It's the s1. So s1, you're going to be 90 minus 100 divided by 12. So with a calculator, you can get it from a calculator. Just change it to 90. It was negative 0. Z1 equals negative 0.83. Okay. Let's go and put it there. Z1 negative 0.83. So that's our Z1. So at our Z1 equals negative 0.83. I make it 18. This is our Z1. Okay. Now we need to get the Z2. We need Z2. I'm going to put right here. Under it, I'm going to put Z2. Change this to 2. Okay. Z2. Now, next will be Z2. Now, we do the same thing to get Z2. I'm going to just copy this and paste it under this. Okay. You got Z1. Where's our Z1? Z1, okay, it's our Z1 right here. So Z2, so guess the Z2. Z2, it'll be X2, which is 120. So I'm going to put 120 right here. Get our Z2. So go to the calculator. Change this to 120. Okay. Give 1.67. 1.67. Okay. 1.67. So I got 1.67. 1.67. Okay, we'll put right here. Which means that the probability that asking us was, say, find the probability that the utility bill is between $90 and $120. So that $90 have been transformed. That means X1, which is $90, have been transformed to Z1. It is no longer 90, it is now 0.83. Negative 0.83, not negative 0.83, that's what it was. And X2, which is the $120, is now changed to Z2, which is 1.67, which means that the probability that is between the two becomes probability of negative 0.83, okay, less than, okay, less than Z, less than 1.67, okay, that is the probability we're looking for now, because they have been transformed, okay. So this is the two I'm looking for now. See, on the left side, negative, on the right, so there are two numbers on the opposite side. For that, we'll be using this formula right here, say part B, which is between two Z values on the opposite side of the mean. So we're going to use this formula to get the answer we're looking for. Okay. All right. What we need. So I'm going to write the Z1 and Z2. We're looking for the probability of P of negative 0.83 less than Z less than R 1.67 equal. Make sure that's what the calculator gave us. Okay, 1.67. Okay, that's what it is. Okay. Now you can go and put this on a cell. Oh, look at me. I'm just rushing me. I'm just writing the formula right here. So you're gonna be equals norm dot s dot dist comma parenthesis z2 true minus norm dot s dot dist z1 comma true. That's what the answer. Let's go and get it. So you have next cell, you got so you have z1 negative 0.83, z2 1.67. Okay, so that the probability we're looking for okay, required probability, we're looking for this probability between these two numbers, two z values. I'm using this formula here, norm dot s dot this parenthesis z2. So I have it right. Now give us then minus the same thing, but this time we're around with this time we use z1. So let's go and get it. So you got equal norm, excuse me, norm dot s dot dist z2, which is 1, comma, true, minus norm dot s dot dist z1, comma, true. That give us, press the enter key to give us the answer. Excuse me, there's a mistake I made somewhere, that's why. I put the small point instead of comma. That's what is it? Where? 1 minute. Let me repeat it. Equals norm dot s dot dist. Okay. So you can see what's happening in Excel when you instead of putting a comma, if you put the small point, answer is messed up. So you gotta be careful. Z21, this will comma true minus norm dot s dot this. Z1, comma, true. Then close parenthesis, then press enter key. Give an answer right away, which you can change to 4 decimal places, which is 7497, 7493, 0.7493. And go over there and put it right there. So 0.7493. Yep. Any question on that? Okay, no question. Good, great. And next will be the last one we're solving tonight will be part C, which is said find the probability that the utility bill will be more than 140, more than 140. So our x is 140. So in this case, part C, our X is 1/4, and say more than that, more than $1/4. Okay. Now that's part C. Okay, I'm gonna move it down. Part C. Remember that the mean is $100 and the standard deviation is $12. So I'm just gonna put that here. So in this case, our X is $140. And we're looking for the probability that is more than that. It is 18. Okay. Let us transform this first using this formula that we use for transformation. Okay. Now put it right here. So it's gonna be 140 minus 100 divided by 12. So our Z becomes, we go to the calculator again, the calculator, and put this 140. That gives us 3.33. So we're going to write 3.33 as our Z. Okay. So 3.33. 3.33. So it is no longer 40. It is now 3.33. It's no longer X. It's now Z. So we're looking for the more than, see, when it says here, okay, to find the probability that the utility bill is more than 140 becomes to find the probability that is P of Z greater than 3.33. Okay, 3.33. Okay. So for that, you can just choose this. I mentioned, I explained it here. Say for part C, use this formula because Z is on the right tail. So we're going to use this formula here. So we're just going to copy it and put it under it. So you can be watching it as we use it. So it's going to be equals 1 minus norm dot s dot dist Z comma true. So this is going to be, I'm going to copy this. Let's go to the Excel. So I'm going to put 0 here. Got so you got Z equals 3.33. So I require probability equals 1 minus, okay, norm dot s dot dist. Click on this, comma, true, with parentheses. Then press the enter key to give you the answer right away. I can make it to be 4 decimal place, which is 0.00, which is Z greater than 3.3304. So it's a very slim probability. So you can go and put it right there. 0.0004. Any questions on this? Okay, so no question. Good. Now you can try number part A as a practice, and remember, under it I gave the formulas you will use it for them. But for example, try number 8. Number 8 has 2 sides, A and B, and it has the formula right here for part A. This is the formula for part B. This formula. for your practice. Now, next week, we will continue from finding data values, given specific probabilities. Yeah? Any question before we leave? Any question before we leave?
You're gonna put this on Canvas, right?
It's already on the handout is already on the canvas, so you just gotta follow the directions there. The formula is the video. Are you talking about the video, sir?
Yeah.
Or the video, just once you type my name in YouTube, all my videos will pop out. I can put it there if you want me to put it there. I can put it in the part of, and yeah, I can put it. I can put it in the classwork before the class where you see the classwork. You see a video.
All right.
You can just
I
watch
clicked
it.
on the classwork and I didn't see that no questions.
Yeah, I'm gonna put it after we end.
All right.
So I'm gonna put this video. So just when you finish the class, just give me an 1 hour to process the video. Then I'll put it right there. All right, guys. See you next week. Have a nice evening.
Professor,
Yes, sir.
did you do attendance?
Yep. What's your name?
Rexam.
Yeah, I have your name already.
You said what?
You didn't get my name either.
Okay.
Yes, I have your name. Bullock.
I'm having some trouble recognizing your voice. Could you tell me your name?
My name?
No, I'm sorry. That was my Alexa, but you said do you have my name?
Yeah.
Okay.
I see what happened there.
Get me down, Professor?
Huh?
Did you get me down for attendance?
What's your name?
Nathan.
Nathan Bullock. Nathan.
Nathan Corte, QUA.
Yeah, I got your name right here.
All right, thank you.
You're welcome. So, guys, I'll see you guys next week.
I have a question.
Yeah, go ahead.
For the last like 2 or 3 assignments, there's no instructions on how to complete them.
No, there's only one assignment. There's no instruction. The one you see last week, I removed it and put it for this week.
It
So,
was homework. I wrote it down.
do you mean there's no instruction, or that there's no question?
Yeah, I tap on the assignment and there's no instructions on how to complete it.
Do you mean instruction or question?
Yeah.
Because the instruction is there, just the question is not there yet.
Okay, but they were like past due. So are you gonna put the instructions or
Past due. Okay, let me see what I'm talking. Let me see. None of them is past due. Hold on.
Can you put my name for attendance?
Right here. It's not past due. It's due on.
there was one due on April 5th
Where is
on
it? Where is it?
homework 5 right there. April 5th,
Yeah.
that one.
This is past due. The instruction is there. Let me open it to see. Maybe see. Look, I always say after I finish the class, wait for the Give me 1 minute. Are you talking about the homework?
Oh, that doesn't show up for me.
Are you
Or
talking
maybe
about homework, classwork or homework?
Okay. Yeah, mine says no content. I can send you an email about it. But
Hold on. Are you talking about classwork or homework? There's no classwork.
yeah, homework 5, the one that you clicked on. But when I click on it, it says no content. It doesn't show Pearson. So I guess I have to just go to Pearson on my own.
If I click on it, then it will show up. Then now you click open the PS now. Then that will take you there to work it.
Yeah, I see what you're saying, but that does not show for me.
Why
It
not?
shows no content. I can send you a picture on email.
Did you follow the direction from the beginning of the semester when you asked you to go to access Pearson?
Yes, I've done the previous Pearson assignment.
Maybe you need to call them and see what is going on.
Okay, I will. Thank you.
You're welcome. All right, guys. See you next week.
Hold on. Yo, can my mic work?
What do you need?
Can you write my name for attendance?
What's your name?
Amari.
I have it here already. You've been coming in off and on, right?
Hello.
I come all the time.
Yo.
Well, so okay. I have Amari here already. Who else have a question? So nobody. Okay. So I see you guys next week then.